Okay, this video is going to go through some review problems for our unit test on graphing trig functions. So number 12 says, Matthew is standing at the beach with his family and notices the water level changes throughout the day. The depth of the water increases from a high of 10 feet above sea level at high tide to a depth of 4 feet above sea level at low tide. On this particular day, high tide occurs at 2 a.m. and low tide occurs at 8 a.m. Draw a well-labeled graph. So I'm going to go 2 a.m., 1, 2. I'm going to make this hours since midnight. And 2 a.m. was high tide. So 2 a.m. is 1, 2, 3, 4, 5, 6, 7, 8. No, that is not good. 8, 9, 10. So that's 2 a.m. It's high tide, and low tide occurred at 8 a.m. So 2, 3, 4, 5, 6, 7, 8. This is tide, height, and the measurement is in feet. All right, so we've got low tide at 4 feet. Boom. All right, and with these 2 points, we can assume, because it's tides and because it's a sinusoidal type of function, that this pattern is going to continue. So I notice from 2 to 8 is 6 hours. This is a width of 6. So if I go 6 hours on the other side, 9, 10, 11, 12, this is noon. 1, so that's 4, 5, 6. At 2 p.m., we're back up at high tide. Close enough. And here's a decent sketch to help us out. So here we go. I want to remember that all sine cosine functions go A, and then either sine or cosine, B, x minus c plus d. A is my amplitude. D is my midline. B is the horizontal dilation, which affects the period, and B can be found by taking 2 pi and dividing it by the period. And C is kind of like my starting point. It's my horizontal translation. So I can see if I start at x equals 2, if that's my C value, then I can look at this as a positive cosine graph. So now I'm going to go ahead and find the amplitude and the midline and the B value. To find the amplitude, I'm going to take my maximum value and subtract my minimum value and divide by 2. High tide is 10, low tide is 4. That's 6 divided by 2 is 3. To find D, my midline, I'm going to take my maximum Y value and add the minimum. And that's going to give me a D value of 7, a midline of 7. Now, the period here, since I accomplished high tide to low tide in 6 hours, that means that the period must be 12 hours. So B is 2 pi divided by the period. I'm going to use a B value of pi over 6. So now I can put it all together. Because I know this is a positive cosine, I'm going to start off with a 3 cosine pi over 6. And it's going to be x minus 2, because when x is 2, that's where I start at a maximum. So that's my translation right 2. And then plus 7. So here is our equation. which I'm pretty sure is the next thing I was probably asked for. Yep, there we go. Boop. And it says D as a function of T. So like you should do depth, like you could do depth as a function of time. But if you did X and Y, that would be fine also. Okay. Letter C asks, what would the depth be at 8 a.m.? Well, at 8 a.m., I can see the depth is just 4. Like I can see that on the graph. There is no calculation to do there. No calculation to do. Okay, so when will the water level be a depth of 8 feet above sea level? What I would like you to do is just add a line to your graph and indicate with an X the times that the sea level will be 8 feet. So I'm going to go up to my graph. I'm going to get my ruler, my straight edge. I'm U. I'm going to go up to 8. I'm going to go across. And I'm going to indicate with an X. This is where the depth will be 8 feet. Okay, in your review, I want you to cross off the pi over 4 in number 13, and in number 15, cross off the 2. I'm not going to ask you to graph a period change and a phase shift at the same time. So here are some updated solutions with those changes. Number 13 is an inverse cosine, so center or bottom, center, top, center, bottom, or my 5 points. And I know I have an amplitude of 3. And I have a period change because there's a B value of 4. The B is 4. So the period is going to be 2 pi over 4, pi over 2. C and D are both 0. So on my graph, I'm going to scale up and down my new amplitude. Now I know my period is pi over 2. So I know that this first point will still start when X equals 0. And I know that this point has to be when X equals pi over 2. So I can put the first point down at 0. The question is, what are the scale marks 1, 2, 3, 4 that will lead to pi over 2 here? So what I'm going to do is I'm going to take the period and I'm going to divide it by 4. So if I do pi over 2 divided by 4, that's pi over 2 times 1/4 is pi over 8. So if you think about it, if I count by pi over 8, 1 pi over 8, 2 pi over 8, 3 pi over 8, and then here, this would be 4 pi over 8, which is pi over 2. So let's put down the other points. The first point lands at the minimum. The second point lands at the midline, the maximum, the midline, or sorry, yeah, the maximum, the midline, and then the minimum. And then I could continue this if I wanted. Please make sure when you graph your function, because it's a cosine, you immediately curve your, oh, that's okay. You immediately curve back up from your minimums. For number 14, we have a phase shift, but no period change. So A is still 1. The period is still 2 pi. My B value is 1 because, like, there's still 1 here. That's why the period is still 2 pi. But now C is negative pi over 2. This is plus. Remember, it's X minus C. That means the graph will move left pi over 2, and it also moves up 3. This is a negative sign. I'm going to remember center, bottom, center, top, center. First thing I'm going to do is go up 1, 2, 3. And I'm just going to actually dot in my new midline. It's going to help me make my graph. Then from there, it's just up 1 and down 1. Period hasn't changed. But it's going to go left pi over 2. Now, because my regular scale marks count 0, pi over 2, pi, 3 pi over 2, 2 pi, and I'm moving to the left in the same fractional unit, here's negative pi over 2, center. 0 will be bottom. Pi over 2, center. Pi, maximum. And before, when we would have ended at 2 pi, because we're moving the whole graph to the left, we're going to end at 3 pi over 2. Center. And there is one period of our reflected cosine, or sorry, our reflected sine graph. Okay, so let's take a look at number 15. And remember, for number 15, I want you to please cross off the b value. So the b is just 1 and the period is just 2 pi. Here we have a regular cosine function. So we know it's going to go maximum, center, minimum, center, maximum in a width of 2 pi. I have an amplitude of 4. It moves to the right pi because it's x minus pi, and it goes down 4. So I'm going to set up my amplitude and my midline first. 1, 2, 3, 4. Put that midline in. That's pretty straight. And now I'm going to go, I've already gone up 1, 2, 3, 4. I know this is where the maximum will fall, and down 1, 2, 3, 4. That's where the minimum will fall. I know that this graph goes right pi. So normally, remember, just like the last graph, this would start at 0 and this would start at 2 pi. But if I'm going right pi, the graph will start at pi and end at 3 pi. All right, so pi over 2, same scale. Remember, I said I'm not going to change the scale and move you right and left at the same time. Pi, that's my first point. 3 pi over 2. 2 pi. So 3 pi over 2, 4 pi over 2, 5 pi over 2. And then this last scale mark is like 6 pi over 2. 6 pi over 2. Well, that's just 3 pi. And I wrote my scale marks above the x-axis because I kind of know that I'm going to need to put my points down in this area, because I know the graph goes maximum, maximum, center, minimum, center, maximum. I think that's it on this page. Let's see. Yep, that was it. And then the last problem that I'm going to do in this video is this warm-up problem. This is a great tide problem. Take a second, pause the video, and just make yourself a quick sketch. All right, so this sketch is really just for me. I know that high tide is going to occur at midnight. And that's 10 feet. I'm just going to go like 10. And then low tide is at 4. 1, 2, 3, 4. And it's 4 feet. And that means that if this is 4 a.m., that means at 8 a.m., we would be back up at high tide. I missed. So we know this is the height in feet. And this is hours since midnight. And if I was a guessing person, I would guess that letter B is going to ask me to write the equation. Hey, there we go. So I know this is a cosine function because it starts at its maximum and it starts right on the y-axis. So when I look at my general form, I know that C is going to be 0 because it starts at the maximum. So to find the amplitude, I'm going to go 10 minus 4 divided by 2. And to find the midline, I'm going to go 10 plus 4 divided by 2. And I went through the formulas on these on the first problem in the video. Now, the period here I can see is 8 because it takes 4 hours to go from maximum to minimum. Must take another 4 hours to come back up to high tide. So if the period is 8, B is 2 pi over 8, which reduces to pi over 4. So this tells me my equation will be y equals 3 cosine pi over 4x plus 7. Now, the graph is asking me to go up to 11 p.m. So this is only 10. So 10 a.m. So I'm just going to go 1, 2, 3, 4 noon. And then I don't know if I'm really going to have enough room. Well, we'll see what else we need. See what letter C says. What is the tide height at 6 a.m.? So at 6 a.m., let's see. Well, 6 is right here. That's exactly halfway between. So 6 a.m., watch this. If I go, and I'm going to use the equation. If I go y equals 3, and you can use your graph, but I want to show you how you can use the equation. Pi over 4 times 6 is 3 pi over 2. That's one of my quadrantal angles. I know the cosine because here's 3 pi over 2, and there's 0, -1. It's x over r. I know the cosine of 3 pi over 2 is 0. So I have 3 times 0 plus 7. So at 6 a.m., I'm right here on the midline, which kind of agrees with my graph. That's the midline. There it is. So 7 feet. Hope you found this video helpful. This, in conjunction with the first video, should provide you with some good resources to help you review for your test.